this webinar is, as you can see, all about achieving WELL certification and maximizing your points with less hassle through the use of indoor air quality monitoring. Now, I want to emphasize that WELL is it's not a destination. WELL certification should never be an end goal. It's a journey, and WELL is one step, one tool in your toolkit as kind of a means to an end. But the end is obviously healthier and happier occupants, an improved occupant experience within our buildings. And so with that said, this webinar is about maximizing your points within WELL, making it as easy as possible, and so on. Now, for those of you that are not familiar with Kaiterra, we produce a suite of air quality management solutions. We help organizations from around the globe to create amazing, world-class, healthy workplaces, optimize their building performance, and achieve building certifications, such as LEED, but also WELL, Reset, Fitwell, and so on. We do a lot of webinar programs like this one. We do this throughout the year. I think the next one might be coming up next month. So definitely be sure to check out our events page. You can also sign up for our newsletter, and that way you will find out about any sessions like these as early as possible and have time to sign up. Now, at Kaiterra, we also work on a lot of WELL projects. Myself, I've worked on probably well over 100 WELL projects at this point, and those include some really iconic ones, such as the International WELL Building Institute's headquarters, as well as the headquarters of USGBC for their own WELL certification, and many buildings that you'll be familiar with from around the world, such as the Empire State Building, the Burj Khalifa, and some of the most amazing buildings all around the world. Now, today we're really lucky to have Alessandro with us. I'll just give a quick introduction to myself first. My name is Liam. I'm the CEO and co-founder of Kaiterra. WELL faculty, serve on a couple of the WELL advisory committees, just like Alessandro. So we're both very heavily involved with the WELL building standard and trying to make it as easy as possible for people to get their buildings certified and to create healthier spaces. So with that, Alessandro, I'll let you give a quick
Thank you, Liam. Thank you. Pleasure to be here. So I'm Alessandro. I'm president of BN Corporations. We've been working in the healthy built environment for the past 15 years. You'll see, I'll get into the presentation a little bit later, the background of the firm, but we've been intimately involved in the development of WELL since the very beginning. So I'm also a WELL faculty. I'm also a performance testing agent. So I'm kind of straddling the two sides of the equation, both on the consulting and also the testing side. So I'll share my experience. Thank you.
Awesome. And also a recent IWBI award winner, I think.
Yes.
So
yes. Thank you.
Okay, final piece of housekeeping. This webinar is obviously live. We are real people, but this will be recorded and it is going to be available on demand. So if for whatever reason you aren't able to make it to the very end, you will receive an email with a recording as soon as it's available. It's going to last about an hour, and we'll have a Q&A at the end, probably 10 to 15 minutes. So there is a Q&A tab that you should be able to find within Zoom. And if you do have any questions, you can put them in there. So there's a chat, but also there's a Q&A section. So please put any questions in the Q&A. We'll take those at the end and go through them. And the key topics for today, we will be talking about some of the key features that revolve around indoor air quality within WELL. So basically just the air concept, and specifically what in there can be achieved through performance testing versus continuous monitoring using sensor data. Talk about some of the challenges with performance testing, the differences between performance testing or spot checks and continuous monitoring using sensor data. And then how to make this as simple as possible. So that's pretty much what we will be going over today. I think with that, I'll hand it over to Alessandro to start.
Thank you, Liam. Please let me know if you can see the presentation.
Looks good on my side.
Good. All right, excellent. So just as a quick background, I mentioned we were intimately involved in the creation of the WELL building standards since the very first WELL project in Asia back in 2013. The firm is a global organization. We have 14 offices, started in Shanghai, but have kind of spread out all over the world. And we specialize a lot in green building certifications, but as Liam was mentioning before, really is a journey. So we focus on design, we focus on construction, but also on operations and maintenance of sustainable and healthy spaces. We started as a consulting firm looking at green building certifications, building physics, life cycle analysis, but then had to evolve because of the evolution predominantly of the building standards, but also the requirements that our clients were placing us in terms of what's happening during the operational phase of these projects. So we launched our own software called bSense to track and analyze real-time performance of the spaces that we were providing consultancy for, and then also an on-site testing business, which focuses on energy, but also on IEQ, predominantly on the well performance testing side. So today I'll be talking specifically about more monitoring and testing. So the need for real-time monitoring came out of retail for us, which is the biggest sector that we work on. And when we were doing lead certifications in retail spaces, there would be portfolios of projects that we would certify. So 30, 40, 50 stores at a time across a certain region, predominantly for ESG compliance reasons. However, after a certain period of time, clients would come back and say, well, this is amazing. We've done all these certifications. What's the actual impact on air quality? What's the impact on energy performance? And we weren't able to answer those questions. We would certify a project and then move on. So it was really evident that we needed to focus on monitoring and being relevant post certification to see how we can maintain healthy and sustainable environments. And this is how the need for real-time monitoring was created. In the beginning, it was predominantly energy and air focused, but now has grown into a much larger program that looks at gas. It looks at a variety of different types of air quality components, including fresh air rates, but also looking at water monitoring in terms of quality, consumption. And we've recently launched a digital waste monitoring and digital audit feature where we use photo recognition and AI to do real-time waste audits to figure out contamination rates and diversion rates in real time, all through a single platform. One of the unique things about bSense is that we can get data essentially from anywhere. This is especially important for older buildings that maybe have analog energy meters that are difficult to get data out of without needing to replace energy meters. We can find ways through gateways or even photo recognition to be able to get those analog signals, translate them into a digital signal, and stream it to the cloud. We're also connected automatically with the major green building certifications such as LEED, WELL, and RESET. And we are the only platform in the world that has a two-way sync with ARC. For those that are familiar with ARC, we're able to send data to ARC for real-time LEED and perform certification, but we also can get ARC scores back into bSense so you can use them to visualize your real-time LEED score within the platform alongside your air data, energy data, water data, and waste data. The dashboard is very flexible. When you first log in, you have an organizational view that can be mapped either by client or by region. You can then go into a site-specific view that gives you a high-level snapshot of the key parameters that you want to see. And then you have an individual kiosk, which can be customized with the photo, but then also looking at the key parameters that you want. Those are all hyperlinkable. So then it takes you to a page where you have all of the detailed analytics. The kiosk view can be a public page. So if you wanted to have that on a display, that can be done without having the user have access to the detailed data behind it, or it can be password protected. We've also, similar to Kaiterra, linked up with RESET to introduce their RESET viral index as part of the software that basically takes pollutant data such as particulate matter, carbon dioxide, humidity, and temperature, and evaluates the probability of a virus transmission taking place. So basically, it's saying how optimized is the space in terms of the primary pollutants that can lead to survivability of a virus or a decrease in the immune system of an occupant. We found this to be an excellent way to quickly get a snapshot of how well a certain space is performing, and I'll give an example of that later on in the presentation. So this is a good segue into wellness and occupant wellness within spaces. So probably most of you on the webinar are familiar with the Well Building Standard. It's the leading international standard for how to design, build, and operate healthy indoor spaces. It was born out of the first communication between the medical community and the building community. There's an incredible amount of research. So within the Well Building Standard itself, there's peer-reviewed articles that back up the reasons why certain features and requirements have been introduced, which I think is actually quite a unique aspect of the Well Building Standard. It's organized across these 10 concepts that you see here. Within the 10 concepts, there's 110 features. These are optimizations. And out of those, 41 are mandatory, and the additional ones have points. The more points you get, the higher certification level that you can achieve. Some of them are what you would think would be present in such a certification. For example, having importance on air quality and water quality. But then there's other elements such as hydration, water access. So it's not about just water quality, but it's about actually having access to water and hydration stations throughout your space. Having access to good quality food, but also data and information about what is contained in the food that's being provided on site. Light focuses on visual balance, but also circadian lighting. Movement looks at ergonomics and facilitating movement. Thermal comfort and sound are more about occupant wellness. Materials is about avoiding toxicity. Mind is about cognitive well-being, and community is what links the project site to the community at large. So how the project team can get involved in, let's say, events that are taking place in the community, NGOs, and things that can bring the community together beyond just the individual project site. Best way to show what Well is about is through project images. So this is an office and showroom that we did in Shanghai many years ago. You can see immediately an open office plan, a collaborative work environment, paneling on the ceiling to provide better noise fluctuation throughout the space. This is the main boardroom that can be also used as an exercise area. There's an Xbox behind the TV screen that can be used also as a breakout area. This is the main display room where they would post what kind of events are taking place around the community, but also as an information booth about what well aspects took place in the office to communicate that awareness to the staff. This is one of the offices that has automatic glare control, a lot of biophilia, circadian lighting that would mimic the sun's path. This is the open office space that has these little rooms that can act as basically sound insulation, but also makeshift meeting rooms. So if somebody needed to go take a phone call or have an ad hoc meeting, they can just pop in there without disturbing the rest of the office environment. This is the canteen, promotion of mindful eating, water filtration on site. And then this is one of my favorite images. There's a very strong element of biophilia and connection to nature. And I think a lot of us automatically assume that this needs to be done by having plants in the office. But having design elements of natural materials, so in this case, stone, wood, and bamboo, are also very much biophilic elements that can be incorporated to achieve the same result. Obviously, as you can imagine, air is one of the primary components of the Well standard. It has 4 mandatory preconditions. It has 10 optimizations that add up to a total of 20 points. So that can make a significant difference in your overall outcome and your certification level. So some of them are linked together. You'll see the first precondition is called air quality, in which you have to meet certain thresholds for particulate matter, organic gases and inorganic gases, including TVOCs. And then you have enhanced air quality that basically has a higher threshold of mandatory performance, which allows you to meet points beyond those in the precondition. This is similar to ventilation design, which is focusing essentially on reduction of CO2. And this can be done either through monitoring testing, which we'll discuss in a second, or compliance with ASHRAE 62. This links with the enhanced ventilation, which then gives you points if you go beyond that level. And then I'll point out, obviously, the most important of the discussion here today is feature number 8, which is air quality monitoring and awareness, which gives you points for having indoor air quality monitors that are able to provide data in real time and reporting to the occupants inside the space. One of the defining characteristics of the well building standard is this requirement for on-site PV testing. And as Liam was mentioning before, well really is a process. And the way that IWBI describes the well standard, it's almost like a health label for a building. And this health label needs to be updated over time. And the only way to do that is to really make sure that the data remains relevant and it doesn't drift over time. So one of the things that they introduced, which is very different from traditional certifications like LEED, is that there needs to be an on-site PV test done to verify the performance of certain parameters and that what is said that is done has actually been implemented. So as a PV testing agent, you have to have the license to be a PV testing both organization, and within the organization, the people that are conducting the test have to be authorized PT agents. So there's 2 licenses that need to be achieved in order to conduct the PV testing. And there's 6 pillars which we look at. First is air testing, which I'll discuss in a little bit more detail. There's water testing, which is on-site chlorine levels, fluoride, but then there's also sampling that needs to be sent to a lab. There's thermal testing that's done for dry bulb temperature and relative humidity. There's light testing, which looks at lux levels, circadian lighting, and visual balance throughout the space. There's sound testing, which looks at overall decibel levels inside the space, but also reverberation time inside spaces. This is one of my favorite tests, actually, and this is the photo that's being used here as an example of it. This is a high calibration microphone, and we have to stand in front of it with a balloon, and we pop the balloon, and the microphone can record the reverberation time inside the space. And then the final part, which is probably the most tedious, is the spot check, where in addition to all of the sampling and testing that we've done, we have to run through the entire checklist, the entire well checklist, so every single feature that's been proposed, to verify that the parameters have actually been met, such as, for example, recycling stations and contamination control. So all of that needs to be documented. Photos need to be taken place with the time and location stamp. So as you can imagine, this takes up a lot of time. Up to 30 or 35% of the entire process of a well certification is really dedicated to just on-site PV testing. So specifically with air testing, as I mentioned, there's 3 main buckets. There's testing for particulate matter, so PM 2.5 and PM 10. Then there's gaseous pollutants, carbon monoxide, ozone, nitrogen dioxide, and radon CO2. And then there's a whole suite of volatile organic compounds, and there's a breakdown of each that needs to be done. This is done in 2 different ways. Either a handheld device that's set up for an hour and it runs and samples at location. So this is represented in the photo on the right. And then for TVOC, we have a pump that samples in the air inside these little tubes, which are then sealed off and sent to the lab for analysis, which takes about 2 weeks, 2 to 3 weeks sometimes to be able to get a reply. One of the most important aspects of this are the determination of the sampling locations. It's one of the most controversial and one of the most difficult aspects of doing PV testing. So when we have a request for a PV test, normally it comes directly from the client. It used to come from IWBI or GBCI, but now most contracts are done directly between the client and the PT agent. So what that means is that it's our responsibility to determine, based on the well requirements, how many testing locations are required for a specific space. If we get that wrong, and that GBCI or IWBI declines and says that we have not put the adequate number of testing locations, or the actual location of the testing is incorrect, then the entire test fails and we need to retest. So it's one of the most sensitive parts of it, also because we need access to the location. And there are some spaces like banks where we don't have access to all the different locations in order to do the testing. So this is something that we really take very seriously. It takes up to 2 weeks only just to determine this part. Then we move through the process of doing the testing, getting the review and analysis, and then sending the report to GBCI, which then responds within 20 to 25 days. So as you can imagine, this has a higher cost to do overall. There's also the issue that not every region has a lot of testing agents. So sometimes just basic scheduling of going on site that matches when the project is done, because it has to be during normal operating conditions, that the space is available. So normally it's done at nighttime. It's a time-consuming process. And also there's a limitation on data because it provides just a snapshot of what the status is at the moment in time which testing is done. But that could be a great day, it could be a terrible day. About 50% of all the projects that submit fail on their first try. The majority of those is air quality. There is at least 1 or 2 parameters in air quality that fail. Now, the good news is that you don't have to retest everything if something fails. You just have to retest the specific parameter that failed. But if you think just in terms of time and cost, this adds a significant amount of complexity to the entire process and a lot of frustration when a client is expecting a certification in 3 months and you're 6 or 8 months out and you're still having to retest because of issues that you can't control because you have no data on the air quality until you do the testing. So this is where IAQ monitoring comes in, and Leanne comes to save the day. So one of the many benefits that we have with real-time monitoring is that we get the data right away. So if we install the sensor, we can see if there's issues and we can mitigate for those issues, maybe even prior to an official test. So we do that sometimes. There are clients that want the test and also have monitors in place. So we use a combination of the two. But honestly, if you have the monitors in place, you're able to mitigate for those issues in real time, collect the data, and then you can confidently submit for a well certification without being worried that there's going to be a point of failure, at least on the air side of things. So one really great example of how we've kind of solved air quality issues is with a client here in Hong Kong. This is Goodman, a logistics facilities. We monitor air quality at 9 of their sites, but we were specifically looking at the management offices. So these are very, very small offices within large logistics centers. Normally just, there's the total across 9 of them is only 150 square meters. Now, the difference in these locations is that they're typically in car parks or places where right outside the management office, there's incredibly bad air. And they were seeking a reset certification for these and really had a difficult time in the beginning meeting the standards. So one of the first things that we did is we mapped out all of the locations based on the reset viral index that I mentioned before. This again is a really good way to see immediately if there's any locations that are struggling with overall air quality performance, as you can see in the top left photo. Then from the monitoring data, we can drill down to figure out exactly what is causing it. Why is that performance so bad? And in this case, it was incredibly high CO2 levels during working hours, very high temperature in the winter, and then pollutants, specifically PM 2.5, that were entering the space. So as a first measure, we went in with the low-hanging fruit. We looked at why the temperature was so high, and we saw that people were using space heaters ineffectively. And so we worked with them to lower the temperature set point down to 25 degrees in the room. We're able to achieve an immediate 6% energy use reduction. And we thought that that was a really great start. But then we saw that actually this caused PM levels to increase. And we were kind of bewildered by this. And we found that there is an automatic fan inside the space that is activated when there's a pressure difference. So by lowering the temperature, we essentially activated this fan that was bringing in air from the corridor where trucks were moving around. So we were bringing in polluted air. So then we installed a filter, a 3M filter on the louver, thinking that at least that would mitigate the PM side of things. Quickly, we saw that that was an inefficient solution. There was just too much air being brought in, including the door opening and closing on a regular basis. So we opted to work with a supplier that put in an air recirculation unit that had a fresh air supply intake with a very high efficient filter. And this allowed us to kind of solve both problems. One is by bringing in that fresh air, we were able to lower the CO2 levels. But because there was high filtration in the filter, we were able to also lower the pollutants. So overall, we kind of solved the three issues of PM, CO2, and temperature in one. But that doesn't mean that our job is done, because over time, the filters get dirty. The filters need to be changed. There's human error involved in it. So by having that data, we're able to see when PM starts to rise. We're able to see the difference between outdoor PM and indoor PM as a de facto value for filter efficiency. So we can be going back to the client and saying, okay, it's time to really change your filter. There's an issue that needs to be addressed. Hence the ongoing maintenance piece. None of this would be possible if we had just opted to do some sort of on-site test for indoor air quality. So just kind of wrapping up and bringing the two things together, with real-time monitoring and devices such as the Sensedge Go, we have full compliance on the air quality section for the requirements of testing. So I mentioned before, there's the precondition for air quality, which is A1, which is linked with feature 5 of enhanced air quality. So that's for PM, for TVOC, and gaseous pollutants. We're able to meet all 5 parts of the precondition, and we're able to get 3 out of 4 points for the enhanced air quality section. So that right away is usually one of the most difficult to achieve and the one that is most frequently a failing point for most projects. Then we have feature 3 and feature 6 for enhanced ventilation design. There are options in both of those to prove CO2 performance via sensors. So if we can prove that there's a certain threshold of CO2 levels throughout the space over time for continuous monitoring, we're able to achieve the full points in those. And then obviously for feature 8, by having the compliant monitors and being able to use them as an educational tool to the occupants, we're able to get full points in those. In the thermal comfort category, both the precondition and the features are essentially the same. By having long-term continuous monitoring and being able to provide that data back to the occupant, we're able to get full compliance out of those. So that's a total of 9 points that the IAQ sensors can contribute towards, versus on the PV testing side, we're really just basing it off of prerequisite compliance and achieving the minimum requirements. I'll finish off by kind of showing where the direction of WELL is going towards. I think that generally speaking, the additional cost of PV testing is a limiting factor for projects, especially projects that aren't grade A projects that don't have the budget to spend on having a higher level of certification cost to begin with, because WELL is more expensive than LEED, but then having to pay for a consulting team and then also an on-site testing team. So the direction is to move towards real-time monitoring for all of the parameters. And right now, we are in discussions with IWBI specifically for the WELL performance rating, which is a subset of the Greater Urban WELL building standard, to provide real-time monitoring for compliance instead of on-site testing for almost the entire rating system. So we already know that for air and thermal comfort, we have it covered with the Sensedge Go. We have solutions for light and almost all of sound that can be done through real-time monitoring. And with water, which is the trickiest part, it'll still require lab testing for pollutants, but we do have the ability to do some real-time monitoring for total dissolved solids, chlorine, and some turbidity that can be done in real time, but with slightly lower accuracy. So this is the type of negotiation that we're now doing with IWBI, and hopefully this can be piloted with the well performance rating, and maybe in the future can be a full alternative compliance for the well building standard. So I'll stop there, hand it over to Liam, and I'll welcome questions at the end. Thank you.
Awesome, thank you. Super interesting stories there. So let me pull this back up. Just to summarize, I think, thank you to our team for putting this side-by-side comparison here. Obviously, with a solution like the Sensedge Go, which I'll talk about in a little bit more detail in a moment, you can reduce total cost. The logistical side of things becomes a lot easier. It can often be a lot easier to leave a sensor in a sensitive location in a building where it's been approved by IT than to have somebody walk through that sensitive location of the building. It can be a lot less red tape there. And something that we like to look at is kind of the ROW, the return on sort of well certification or well points, which is just sort of what bang for buck essentially. And there's a lot more points on the table with continuous monitoring if you can measure all of the right things. And obviously Alessandro talked a lot about the difference in value. I think it's one of the unfortunate things about sort of the way that performance testing, it was the only option many years ago. There were no sensors to do these things. So it exists for a very, very good reason. But it is unfortunate that in many projects today, at the end of the day, what happens is a test gets taken, a piece of paper gets output, it gets submitted, and then let's be honest, it gets ripped up and put in the trash. Because it serves one single purpose, which is to get data on the performance of the space at a specific point in time, submit it for certification, and once that certification has been achieved, that piece of paper no longer serves any purpose or has any intrinsic value. And that is very, very different to continuous data. Now, I know there's a number of well APs and experts on the call, so I just want to address one thing which we've seen is there's a lot of people who have been involved with the standard for many years and have an understanding of what was true several years ago. And so just going to do some myth busting here. The myth is that installing air quality monitors gets you 2 points under feature A08, which is install air quality monitors. But then you still need to do the performance testing every year. That is not the truth. The truth is that installing air quality monitors can get you 9 points in total, as Alessandro just shared, and you no longer have to do the performance testing. So at this point, a solution like the Sensedge Go is able to fully replace the requirements for performance testing under the air and thermal comfort concepts. I'm also super excited to see where the future takes us in terms of, and takes the standard in terms of everything that you just talked about, Alessandro, in terms of sort of light and sound and water. I think that's going to be a really interesting future where you just have continuous data on all of these parameters that impact human health. And we know what's going on 24/7, 365 days a year. So I just want to talk a little bit about the solution that can actually deliver on this promise. So specifically the Sensedge Go. The Sensedge Go is really this is released new air quality monitor that we released late last year, and it's really designed around the well building standard. It helps you meet all the requirements, earn up to 9 points. It does this in a much more cost-efficient way and with a lot less hassle. So for those that aren't familiar, just looking through this, this is a device that measures particulate matter, volatile organic compounds, CO2, temperature, humidity, air pressure, light, both the lux levels, but also the entire spectrum. So how much red light, how much blue light. It measures occupancy. And it can also measure ozone, carbon monoxide, and NO2. I know there's a comment about our question about carbon monoxide that popped up. This device runs on battery. It can run for up to 8 years on battery, which is really incredible. And that is not sort of giving you one reading every few hours. That is actually with a really high sampling rate. For many of those parameters, you're getting one reading per minute across 8 years. It is fully battery powered, but if 8 years isn't enough for you, you can also still plug in a USB cable and you can run it forever. And of course, it can connect to the cloud. You can get all the sort of the reporting, but it can also connect to your building management system. And I won't spend any time on this since I think Alessandro, you kind of covered this. But if anyone wants to take a screenshot, go for it. This shows the actual parameters that are required under A01. That's the precondition, and how each of those is met, as well as the exact features and points for each of those optimizations. So this is what's really different. That historically, air quality monitors have not actually measured all of these things. So most monitors on the market today, for example, do not measure carbon monoxide or ozone. Those two are both requirements under A01. So that's why historically, I think we've had that awkward situation where you've seen projects that install monitors and they get a couple points under A08, but then they also need to do performance testing because they're not measuring everything that they need to. And they still need to do annual performance verification every year. And so that leads to this awkward place where you're basically doing two things and doubling your expenses. But if you have the right solution, which is measuring all of those parameters that are required, then you can completely replace PV testing. And one of the concerns that we have heard a lot in the past is that it can be too expensive and too hard to install sensors. So, for example, if you are doing a big building, especially if it's a retrofit, when you're weighing the options of should I do testing on site or should I install continuous monitors, one of the challenges that historically has come up is that, especially in a retrofit, installing monitors can be expensive. You need to run cables. You might need to bring in extra switches for your Ethernet cables to run to. And those costs can quickly add up. And so that's why the Sensedge Go has been designed to be entirely battery powered. It can basically, you just pull off the double-sided tape on the back, stick it on the wall, tap your phone against it, and it connects to the internet. Our current record for installation time is 46 seconds from taking the device out of the box to getting it reporting data into the cloud. But on average, we see this taking between about 1 to 2 minutes per device. So recently we did a big project on the west coast of the US, and all of the monitors were installed over lunch break by the office admin. So you don't need a specialist with training. It's fast and easy to install. And we've also done a lot of work around reducing the number of gateways that are required. So these sensors talk wirelessly to a gateway, but we've done a lot of work to reduce the total number of gateways. So one gateway can cover 3 to 5 floors easily. It can have 50 to 100 devices talking to it. And so that really minimizes the number of extra pieces of hardware that you need. We've also done a huge amount of work to make the battery last for a really long time, up to 8 years using our adaptive sampling technology, 4+ years if you have a high frequency fixed sampling rate. And so that is about 4 times longer than the next best thing that is available today. And the reason this is so important is because there are many hidden costs when it comes to sensors. So oftentimes what people look at is sort of the price tag on a sensor, and they say, well, I need 20 sensors, they cost X dollars, X times 20, that's my total number. The reality is that there are costs that people are often not aware of, so installation costs. With a wired solution, in a new build, that can be very reasonable, but if it's a retrofit, those costs can add up really quickly. I've seen a lot of projects where installation costs were 80% of total project costs, so significantly more than the actual monitor. Other hidden costs include the gateways and maintenance costs, so replacing batteries. If your batteries are able to last 4 times as long, that has a huge impact on maintenance costs. If you only need 25% of the total number of gateways, again, that has a huge impact on those gateway costs. So sort of when looking at the Sensedge Go versus a similar solution, you'll see that you need many fewer gateways, much less time spent on install, and time equals money, and a lot less maintenance both on batteries, sensors, recalibration, etc. So the Sensedge Go is a very, very, very cost-effective solution, not only compared to some traditional methods for testing, but also other options for actual continuous monitoring as well. Now, again, towards the end here, I'll just share a couple features that I think people are going to love. One of the other drawbacks to sensors is if you have a lot of them and you need to submit that data for well, it can be a lot of work to process all of that data. It can be a lot of work downloading spreadsheets, filtering out working hours, non-working hours, occupied hours, not occupied hours. This one's in a kitchen, this one's not in the kitchen, because these are all treated differently under well. Taking all of that information, formatting it in a format, in a spreadsheet that IWBI requires for submission, and then submitting that. We hear people spending 80 to 100 hours doing this. The good news is that we have automated that process. So not only are the sensors collecting data that is compliant, but the data is output in a format that is compliant with a simple pass or fail result. So to the point that you had earlier, Alessandro, about not knowing if you're compliant until it's too late. When you're 3 months out from your certification, you can actually just look at this data and know very, very easily, am I compliant or not? Now, I've talked a lot about the well requirements, and I think it's worth sharing how well is just a standard, but actually it represents a sort of fundamental shift that is taking place in our industry from, I think, box ticking to measuring actual performance. And obviously this is amazing because, yes, it makes our certification process easier, but it also adds so much extra value. There are so many use cases, and I won't get into all of these, but if anyone that's watching the recording wants to pause and read, then go for it. There are all sorts of use cases and benefits outside of just your certification, be it engaging with your employees, be it contributing to your social sustainability initiatives and your ESG reporting, holding your landlords accountable because you have reports that you can show them that shows the actual performance of the building. And many, many different people throughout the business can benefit from this, be it the CFO, the head of facilities, your VP of workplace, or your CEO and your board who are championing a culture of health and well-being and caring about their employees. There are many, many different ways in which this data can be utilized and transformed into something that resonates and adds value to different stakeholders throughout the building. I was posting about this on LinkedIn yesterday, and somebody commented, everybody should be involved in IQ of a building because we're all breathing the air in the buildings. I'll just wrap up on a couple quick examples of some of the use cases outside of pure certification. So Salesforce has a large number of Kaiterra monitors installed in many of their offices, and they use these devices to hold their landlord accountable, to understand building performance, to enable their operations teams to manage their filters better, as Alessandro was describing earlier, to stay on top of when these things need to be done, to set alarms, understanding if there's a wildfire and how they need to handle it. And they have seen a huge improvement. They've seen a 90% reduction in PM2.5 levels when there are wildfire events because they've been able to hold their landlord and facilities teams and firms like JLL and CBRE that they work with. They've been able to hold them accountable and provide them with the data so that they can do a better job. It's a major tech company in Silicon Valley. In 2024, they started using Kaiterra sensors. They had sensors before. They're pulling those out and putting these ones in. And they're started with a pilot in one building. It's moved to a very high density fit out of a couple offices in India. And over the next year and a half, they're rolling these out through all of their offices so that they can report centrally on the air quality of their global portfolio. They can use it for ESG reporting and so on. I have another example from one of the busiest airports in the world, in the US. They started with monitors in one single location for a well certification in order to replace performance testing. And that has expanded into their new terminal because they've realized the impact that they can have by measuring air quality in such a busy location where there can be challenges with outdoor air quality at an airport. And it's really, really important. You've got millions of people going through your terminal every year. You absolutely, actually, probably more than every year, it's probably every day. You need to understand what the impact on their health is. And so this is also morphed into a full rollout throughout the airport across all terminals that are being built, office buildings, and other facilities. So there's a lot of applications, again, outside of certification. If you are doing certification, I think it's a no-brainer to start using sensor data and continuous monitoring. But with that, let's jump over to our Q&A. I think there's a couple questions there. So if you have any questions that you haven't asked yet, now's the time to put them in the chat or in the Q&A section, so I should say. So first up, we've got one here. Thanks for a fascinating presentation. It looks like your real-time monitoring does not include carbon monoxide. Wondering why not and what your views are on the paper that was released last year on concentration thresholds. Oh, this is an interesting question. I'll answer the first part of that, and then maybe Alessandro, feel free to jump in as well. I think historically, carbon monoxide, as I talk about later, we do now offer carbon monoxide, and I think it is really beneficial in certain environments. If you're, for example, the example where it's next to a parking garage, absolutely, you should be measuring carbon monoxide in a place like that because there's a high risk of exposure to it. I don't think everyone should be measuring CO in all of their office rooms and their phone booths and their meeting rooms because that increases your cost for not really any good reason. But there are certain locations in buildings where I'd absolutely say it should be done. Alessandro, sure if you've got thoughts on this one.
No, I mean you you pretty much covered it already. Like we don't normally include a carbon monoxide because a lot of the requirements that we have are driven by certification, and carbon monoxide is only one of the options for compliance. But now that we're shifting towards ongoing monitoring as a replacement of PV testing, it's going to be something that we need to install on every project. But I can't say it's something that we have a very high demand for from clients.
Yeah, no, it makes sense. I think one of the ways that we often look at it is when we're looking at a project that's going after well certification, is look at the minimum number of monitors required by well. That might be, for example, 10 monitors. And those 10 should measure carbon monoxide because it will help replace PV testing. But that 10 monitors could be quite a large project, and that's nowhere, that's not enough to get a really good picture of your air quality. You won't cover all the spaces that you probably should. And so we'll generally suggest, well, in those spaces, maybe, use 10 that are measuring carbon monoxide, but maybe put another 10 monitors in, put another 15 monitors in your conference rooms that are measuring CO2, TVOC, and you can reduce your cost that way. So kind of find a good balance.
I think this goes on to the next question actually quite well, Liam, because the next question is, do you recommend monitors everywhere? Should they be everywhere? And how do we bring down the cost of real-time monitoring? So in our experience also, because we're quite involved with the reset standard that has been looking at setting up the best possible way in which monitors should be set up and streaming data for certification. They've basically created the standard of how that should be done. We have seen that there is the average air quality spread out across spaces is relatively uniform, especially if you have larger spaces. So the initial reaction would be to install a monitor in every single space. That has not proven to be required. There doesn't seem to be a major difference in the results that you get by having monitors in every single room or sampling them accordingly. If you look at the requirements for well certification, the minimum number of monitors vary by occupant size. The smallest is every 350 square meters. Then it goes, if for larger projects, it goes to every 500 square meters. And then for very large projects, it's one for every 1,000 square meters. And that is relatively sufficient in order to get an idea of the snapshot at any single point in time of what the air quality is. We do, however, like what Liam is saying, sometimes put the minimum number of monitors correctly placed in the larger rooms to get a sample of what the air quality is overall, but intelligently placed, right? So they're furthest away, for example, from recirculation units if they're there. We have to choose the locations that are worst in terms of air quality. In the example of retail spaces, this is one back and forth, an argument that we've had with GBCI quite a lot, because initially they required the air quality monitors to be in the sales area of retail spaces. And we fought very hard not to do that, because the worst air quality is going to be in the back of house. So if we're going to monitor one place, it has to be in the back of house, not in the sales area. We can already assume that the sales area is going to be better than the back of house. So, intelligent placement, reduction in them. But then if we have specific issues like carbon monoxide because we have an entryway that's near our car park, then just put a carbon monoxide sensor, not necessarily the entire suite of sensors in that location. So that you can reduce the total number of monitors and the cost and get a very accurate representation of the air quality.
Yeah, no, I think that last point for me is quite key, which is being intelligent about where the monitors are placed and not measuring more than you need to. We generally suggest measuring in things like conference rooms, measuring as many as possible, but not measuring all parameters. And the reason for that, it depends a little bit on what your goals are. You can identify a lot of issues with mechanical systems that start to fail. So almost more fault detection. If you were seeing 5 air exchanges, air changes per hour, and that suddenly drops down to 3 air changes per hour, that signals that there's an issue with maybe the fan coil unit or the VAV box that's delivering air into that specific room. So that can be very useful to flag. But you don't need to measure 8 parameters in order to identify that, which massively increases your cost. So there's the opportunity to sit down and kind of work out, say, what are your goals and what's the right combination of monitors to get there, and density, I think, is a really important step. So we've probably got time for a couple more questions. We will see, what do we have here? Is there a display or alarm option, e.g. for a busy school teacher to remind them to open the window if CO2 goes too high? What level would you recommend? Just very briefly on the Kaiterra platform side, absolutely. And I'm sure, Alessandro, on your side, it's the same thing.
Yes, that's correct. Yeah.
Yeah. As for the exact level of CO2, I think there's a lot of different options. Well, for example, has 900 ppm as an initial threshold, and then they've got an enhanced ventilation threshold of 750 ppm. I generally think those are pretty reasonable numbers to work with. We've got a question here. Could Alessandro give some more detail about the virus estimate, please? So based solely on CO2, relative humidity, anything else?
So it's a combination of CO2, which is a de facto value for virus concentration. So the idea is that the CO2 is high, there's more people inside the space speaking increasing CO2. So if there is a virus, it's more likely that that virus is going to be present in a higher concentration. Then you have TVOC and particulates, which are de facto values for human health. So the idea would be that if these pollutants were increased for a longer period of time, then the occupants would have a lower or a more compromised immune system. And then we have temperature and humidity that are looking at virus survivability. So viruses usually die in the range of 30 to 60% relative humidity. So we have spaces that are very dry or very humid, then we have an increased likelihood of virus survivability. So they take all those parameters together and then evaluate them and output a percentage value that determines how optimized the space is. So it's looking at all of those parameters together.
Awesome. Take one more here, and then I think we're probably going to have to wrap up. We got a question. We actually got a couple questions around calibration of sensors, lifetime of sensors, maintenance needed, and so on. So at Kaiterra, we design all of our sensors to make sure that they are, or all of our air quality monitors to make sure that they're very easy to recalibrate, because the reality is that technology is not perfect. All sensors have a potential to drift over time or to experience some sort of failure or issue. I mean, I've seen a sensor measuring particulate matter that had a spider web inside. So, there's all sorts of unusual things that can happen. And the well building standard, I think very rightly, does a good job of mandating that sensors be recalibrated. So you cannot use a sensor that's 10 years old, no one's ever looked at it, to prove that your building is healthy, because those readings might not be right. So there are requirements around that. Within our devices, sensors are in these sort of modular capsules that you can replace, and so that you can easily recalibrate those. For the sensors which need to be recalibrated, the reality is some things like temperature and humidity last forever. Almost certainly the lifetime of the device without needing recalibration, whereas other sensors may need to be recalibrated more frequently. I could talk about this for a half hour, but I won't. And we're at pretty much at the hour here, so I think we will wrap this up. If there are any further questions, any questions we didn't get to as well, we'll take note of that. If you've left your name, feel free to we can potentially reach out with answers to those questions. And so just big thank you to Alessandro for joining. Thank you to everybody else for being here. Again, can find both of us on LinkedIn. Subscribe to our newsletter if you want to know about more upcoming events and webinars like this. And again, thank you for being here. Hope to see you at the next one.
Thank you, everybody. I appreciate it.